Okay, so I'm going to look at this thing and say, can I solve this without logarithms? That is, can I write the number 7 and the number 5 with the same base? Well, I don't think so, right? Because 5 to the first is 5, and 5 squared is 25. There's no way I'm getting to 7 out of that. So I need logs. All right, so I'm going to do this, and let's do this 3 ways. I'm going to give you 3 solutions here. And I can also kind of show you why that change of base formula works. So I'm going to solve this 3 different ways. Okay, the first 2 ways are how I would typically do it. You pick one of our bases that show up on our calculator, right? If you look at your calculator, you got a natural log button, and you have a common log button, log base 10. So that's what I would choose, right? Your obvious choice would be log base 5. But I'm not going to do log base 5 because I can't, it's not on my calculator. Now, you could do it. Let me just show you the 3 ways. I usually take the natural log. I use the property that brings the power down. X times the natural log of 5 equals the natural log of 7. Divide both sides, and I'm done. All right, that's my exact solution, ln 7 over ln 5. And if I take a second to put that in my calculator, and I get about 1.209, I'm going to round that to 1.21. And again, this I'm going to talk about this a lot. This is my exact answer. And that's exactly what x is. And this is my approximate answer. Right? Because it keeps going, dot, dot, dot. All right, so that's one way to solve. How about I take the common log? That's on my calculator, common log of both sides. Well, I can use the same property. Log base 10 of 5 to the x is equivalent to x times the log base 10 of 5. And that's equal to, I took the log, common log, or log base 10 is 7. And look, I get the same kind of situation here. To solve for x, I would divide by log base 5. Okay, now here's where I can show you that change of base formula works. So we can jump back to change of base. If x is equal to the natural log of 7 over the natural log of 5, but it's the same x, common log of 7 over common log of 5. You can check that. I guarantee you that's going to be about 1.2 if you plug that into your calculator. Then that kind of verifies, well, I'm getting a little ahead of myself. Let me show you the third way to do this. The third way would be to take the log base 5 of both sides. Right? That's the logical thing to do because it's less work. Because then I can use my property where the bases are the same. Because the log base 5 of the x is just x, and I get one answer. Now, the reason I don't really like this way is because I don't have a base 5 in my calculator. Now, some of the nicer calculators, you can pick your base. And this should be 1.21 approximately. So this would be okay too. I mean, I would accept any one of these answers. If I say find the exact solution, this, and this are all acceptable. They're all the same thing. And then the approximate solution, this is why I use the natural log, because I can plug that into my calculator. Okay, and now this is where I can show you how that change of base formula works. Remember the change of base formula, if I asked you to change the base of this thing, you would say, well, let's see, that's equivalent to, and then you can pick any base you want up top. So let's pick the natural log, and then you put this number up first, and then you take the natural log of the base itself, right? And that's using the change of base formula to go from here to here, and these have to be equivalent. But we already saw that because we did it by our other properties that we got this. So these are all the same, and this kind of shows you that the change of base formula works. Okay, so I hope that makes sense. Let's do some more. This next one I recognize as not needing a logarithm. This one's easy. So as long as I can recognize as 4 as 2 squared, then I do this trick. And I equate my exponents. Remember, I'm multiplying here. So that's 6x is equal to x minus 1. I can just drop those exponents. Easy. 5x, subtract x from both sides equals -1. Divide by 5, divide by 5. And my solution is -1/5. Okay, you can check that. I'll skip the checks for the sake of the video length. But if you plug that in, you should get the same thing on both sides. All right, pretty sure I can't do the equal bases here because I have base E And I don't know any other bases that are going to be equal to, or there's no way I'm going to have an e on the right-hand side, right? So I would do my basic algebra to isolate the exponential expression. Divide by 2. So that's all old algebra stuff. So it gives me e to the 3x equals 9. And again, at this point I say, well, I don't know how to write 9 as e to some power. E to the second, I don't even know what that is. E to the third, I don't know. So I got to be forced to take logs. And this one has an obvious choice, the natural log. Right? The two properties we're using is this one. That's what I just used. And then there's this one where the bases don't align. And the end comes down and you're left with log base a of b. That's this property we had to use for these guys. This one and this one. This property we used when we did it this way and got right to the answer. Base, base, align. And that's what I'm using now for this one. All right, so I go back and forth between these two properties. So on the right-hand side, that's just a constant natural log of n. And then I divide by 3. And I'll leave this one as exact. If you want the approximate, you plug that into your calculator. All right, here's our first pretty challenging problem, number 5. And the reason I say that is, well, if I could write 18 as base 2, so 2 to the second's 4, 2 to the third is 8, 2 to the fourth is 16, so I just miss 18, so no good there. So this one's going to be tricky. So which log do we want to pick? I'm going to do the natural log. Okay, again, there's going to be multiple ways to solve all of these. Bring the exponent down. This one's going to be a little messy. If you like algebra, you're going to like this problem. So I just take the natural log of both sides, bring the exponent down, use parentheses. All right, and again, start thinking of this as just a single number. I can use parentheses if I want, just to encompass that. The natural log of 4, that's just some number, 1 point something, right? E to what power gives you 4? 1 point, I don't know what. But anyway, just think of it as one number, okay? One number. It's like 5 times x minus 1 or 10 times x minus 1. Now this one's tricky because we have to solve for x, and there's an x here and an x here. All right, so the process is going to be to get all my x's on one side, everything else on the other, and I have to do that by distributing. So stay with me. Natural log of 4 times 2 times x. Here's how I'm going to write that. 2 times the natural log of 4 times x. That's my constant. I'll group that together. Minus 5 ln 4, that's a constant. Natural log of 18 times x. The reason I do this is because I don't want to write, if I write it like that, that can be a little confusing. Like, is the x part of the input to natural log or not? Well, I don't want it to be. That's why I say, okay, natural log 18 is a number times x. Okay. All right, pretty ugly, but I got 2 x terms and 2 non-x terms. So I'm going to move this over, this x term. It's like subtracting 5x from both sides. I'm going to add this to both sides. So it goes away here, goes away here, and then I have 2 ln 4 times x minus ln 18 times x equals, I'm going to just rearrange this so my negative guy's second. Oh, did I write that twice? Yeah, so just 5 times the natural log of 4. 5 ln 4 minus the natural log of 18. Okay, now why did I do that? Because I'm trying to solve for x. So now the trick will be to factor it out. So I have an x here and here, so I factor out, I get 2 ln 4 minus the natural log of 18 equals 5 ln 4 minus ln 18. I'm using ln or natural log interchangeably. Say either one if you want. And then my final step is just like if I had 5x equals 12, I divide both sides by 5. This thing times x equals this thing, so I divide both sides by this thing. This is one of the more complicated ones you'll have to do. And there's my solution. Again, if you want that as a approximate answer, you have to run it through your calculator. Now be careful, here's a separate lesson. Don't do this. I see students do that all the time. If you're multiplying on top and bottom, you can do this. because 1 divides the other evenly. Natural log 18 divided by natural log of 18 is 1. But in this case, you're not dividing, you're subtracting. Okay, so you'd have to leave it like that. The example I always give my students is 2 minus 1 over 5 minus 1. Is that equal to 2/5? No, you can't. If you cross the 1's out, it'd be equal to 2/5. 2 minus 1 is 1. This is 1. 2 minus 1 over 5 minus 1 is 1/4. It's not equal to, if you did that and that, killed the 1's, 2/5. Not equal to 2/5. Okay, so don't do that here.